Morning friends. In the last lecture we have seen Euler's theorem, examples on Euler's theorem. Now in this lecture we will see the corollaries of Euler's theorem, which I have just mentioned in the last lecture. So the corollaries are: if z is equal to fu is a homogeneous function of degree n in x and y, then x dou z by dou x plus y dou z by dou y is equal to n into fu by f dash u. Second corollary is: if z is equal to fxy is a homogeneous function of degree n in x and y, then x square dou 2z by dou x square plus 2xy dou 2z by dou x dy plus y square dou 2z by dou y square is equal to n into n minus 1 into z, or gu into z dash u minus 1, where gu is n into fu by f dash u. So either you use this result or you use this result according the example, how the example is, and what is the expected answer. Accordingly, you just select one of the result, either this result or this result, for x square dou 2z by dou x square plus 2xy dou 2z by dou x dou y plus y square dou 2z by dou y square. So these examples, you can prove these examples, these corollaries also you can prove. That is, I suppose it is homework for you. You just treat this as an exercise. Examples are important from the point of view of examination. So if u equal to sine inverse x square y square divided by x plus y, show by Euler's theorem that x dou u by dou x plus y dou u by dou y is equal to 3 tan u. Is equal to 3 tan u. So here we observe that u is not directly homogeneous, as it is sine inverse of this one, and we cannot take out etc etc, and therefore this is not directly homogeneous. But if we assume z equal to fu and fu is sine u, that is sine u is sine of sine inverse, that is x square y square upon x plus y. So this x square y square upon x plus y is homogeneous. How? From numerator we take x raised to 4 common. You see, it is into x raised to 4 common, therefore what you are getting? Y by x, y square by x square. And from denominator we take x common, x into 1 plus y, so that x raised to 4 by x is x cube, and whatever remains is a function in y by x, and therefore we conclude that our z is homogeneous of degree 3. Or it will be clear by the following method. You can use this method by putting x is equal to xt, y is equal to yt, etc. And I suppose the such type of examples also we have seen in our last lectures. So it is also t cube into z of xy. So from both the things we conclude that our z is homogeneous of degree 3, and therefore by corollary of Euler's theorem, x dou u by dou x plus y dou u by dou y is equal to 3 into fu by f dash u, that is 3 sin u divided by cos u, because fu is sin u, and its derivative f dash u is cos u. So 3 tan u, which gives 3 tan u means the RHS of the result. So thus the statement is proved. Next example: if u equal to log of x square plus y square upon x plus y, show by Euler's theorem that x dou u by dou x plus y dou u by dou y is equal to 1. Here also this u is not directly homogeneous, but if we assume z equal to fu equal to e raised to u, E raised to u is e raised to log of this. So that is x square plus y square upon x plus y. And therefore z of xt yt, by using this method we put x is equal to xt, y is equal to yt, so that we will get t square into x square plus y, t into x plus y. So t z of xy, which shows that z is homogeneous of degree 1. And therefore by corollary of Euler's theorem, x dou u by dou x plus y dou u by dou y is equal to n. N is 1. 1 into fu by f dash u, e raised to u by e raised to u, that is equal to 1. Fu is e raised to u, therefore f dash u is also e raised to u. So the result is proved. Next example is if u equal to x square phi of y by x plus x psi of y by x, find the value of x square dou 2u by dou x square plus 2xy dou 2u by dou x dou y plus y square dou 2u by dou y square by using Euler's theorem. So here u is the sum of this and this, and therefore first term we assume as u1 and second term we assume as u2. So u1 is x square phi of y by x, and it is clear that this is homogeneous of degree 2. u2 is x raised to 1 psi of y by x, therefore it is clear that u2 is homogeneous of degree 1, and therefore apply Euler's theorem for u1, your corollary of Euler's theorem for u1, corollary of Euler's theorem for u2, so that we will get x square dou 2 u1 by dou x square plus 2xy dou 2 u1 by dou x dou y plus y square dou 2 u1 by dou y square is equal to n into n minus 1 into u1, the first result. So that is 2 u1. N is 2. 2 into 2 minus 1 into u1. Similarly, for u2, you are getting x square dou 2 u2 by dou x square plus 2xy dou 2 u2 by dou x dou y plus y square dou 2 u2 by dou y square is equal to n is 1. 1 into 1 minus 1, that is 0 into u2, 0. So add these two. So first term addition, x square dou 2 u1 by dou x square plus dou 2 u2 by dou x square. Second term 2xy is common, dou 2 u1 by dou x dou y plus dou 2 u2 by dou x dou y. In the third term y square is common, y square into dou 2 u1 by dou y square plus dou 2 u2 by dou y square. So that this first bracket is u dou 2 u by dou x square. Second bracket is dou 2 u by dou x dou y, and third bracket is dou 2 u by dou y square. So that, and the addition of RHS is 2u1 plus 0, that is 2u1. So that we will get x square dou 2u by dou x square plus 2xy dou 2u by dou x dou y plus y square dou 2u by dou y square is equal to 2u1, that is 2x square pi of y by x. So what we have done here, since u is sum of this and this, so we separately apply Euler's theorem for this, corollary of Euler's theorem for this, corollary of Euler's theorem for this. For this, the degree is 2, n is 2. For this, degree is 1, and therefore we can have these two results, 1 and 2. We add these two and directly we will get this result. So I suppose the example is clear. Such type of examples you can construct and you can solve of your own. Next one is, if u equal to sine inverse of x by y plus tan inverse of y by x, prove by Euler's theorem that x dou u by dou x plus y dou u by dou y is equal to 0. If it is sine inverse, log, cos inverse, cosec inverse, tan inverse, and if in the bracket whatever x and y's are there, if degree of this numerator and degree of denominator is the same, then the whole function is homogeneous. In the last example we have seen, that is this example, log of x square plus y square x plus y. So log of this one, x square plus y square, means degree is 2 and here degree is 1, and therefore this is not directly homogeneous. But this one is homogeneous. Why? Degree of numerator is 1, degree of denominator is 1, x by y. Here also the same thing, and therefore we are having both these u1 and u2 homogeneous, and their degrees are 0. Their degrees are 0 because here it is not mentioned 1 into sine inverse of x by y, but 1 is there, as 1 is the multiplicative identity, and 1, that 1 we can write as y raised to 0 because x by y is here some function in x by y, and here we write x raised to 0 because some function in y by x, and therefore both u1 and u2 are homogeneous and their degrees are 0, and therefore we apply Euler's theorem for both separately. So Euler's theorem for u1 gives x dou u1 by dou x plus y dou u1 by dou y is equal to 0 into u1, that is 0. n z is u1 and n is 0, so 0. Similarly for u2 also you are getting x dou u2 by dou x plus y dou u2 by dou y is equal to 0. If you add these two, you are getting x into dou by dou x u1 plus u2, first term, addition first term, x is common, addition of second term, y is common, so that final answer you are getting as x dou u by dou x plus y dou u by dou y is equal to 0. The next example is like this. If u equal to cosec inverse, show by Euler's theorem that x square dou 2u by dou x square plus 2xy dou 2u by dou x dou y plus y square dou 2u by dou y square is equal to 1 upon 12 tan u into 13 by 12 plus tan square u by 12. So here this is not directly homogeneous. Therefore we assume z is equal to fu is equal to, since it is cosec inverse, cosec u. So fu is cosec u, and this one is like this, root of x raised to half plus y raised to half divided by x raised to 1/3 plus y raised to 1/3. From numerator x raised to half is common. What you are getting is this one, 1 plus y by x raised to half. From denominator x raised to 1 by 3 is common. What remains? 1 plus y by x raised to 1/3. So that law of indices, x raised to half minus 1/3, and whatever remains is the function in y by x. So this one is x raised to 1 by 6, but in the square root x raised to 1 by 6 means without square root, if you remove the square root it becomes x raised to 1 by 12, and whatever remains is the function in y by x, and therefore from this our conclusion is z is homogeneous of degree 1 by 12, and therefore we use the second result of that corollary. So by corollary of Euler's theorem, x square dou 2u by dou x square plus 2xy dou 2u by dou x dou y plus y square dou 2u by dou y square is equal to gu into z dash u minus 1. But what is gu? gu is n into fu by f dash u. So what is fu? fu is cosec u. What is f dash u? Derivative of cosec u minus cosec u tan u. So cosec u gets cancelled. In the bracket you are getting minus 1 upon cot u. So minus 1 upon cot u means minus tan u, and therefore this becomes minus 1 upon 12 tan u. And gu is this one, therefore its derivative gives minus 1 upon 12 sec square u. So put gu and z dash u in this, and you will get minus 1 upon 12 tan u minus 1 upon 12 sec square u minus 1. This sec square u you can write in terms of 1 plus tan square u, because in your answer there is no sec, there is only tan, and therefore this sec square u is 1 plus tan square u. And this minus you can operate here, it minus minus becomes plus, this minus minus becomes plus, and you just try to simplify this. I will not give the details because it is just the addition, subtraction, etc, etc, and therefore finally you are getting x square dou 2u by dou x square plus 2xy dou 2u by dou y square plus y square dou 2u by dou y square is equal to 1 upon 12 tan u into 13 by 12 plus tan square u by 12 as per our requirement. So the result is shown. I suppose such type of examples also you can solve at home. Try to use the techniques of the derivatives or homogeneous functions or Euler's theorem, corollaries of Euler's theorem, so that you can become perfect in all these things, and at the time of examination you can solve the examples on this particular article very easily without taking any tension, without ambiguity. So I suppose for today it is sufficient. If you are having any difficulty in understanding, please ask your difficulties, because I observe again that from mechanical 150 plus students are in the WhatsApp group, and for electronics group 60 plus students are on WhatsApp group, and therefore in all 200 plus students are on WhatsApp group. But the views, if I see the views for these YouTube videos, then only 30, 40, 50, 60 views are there, and I suppose this is not good for you, because all these topics are included in your degree course. If you complete the diploma and take the admission for degree, then there comes difficulty in mathematics only. You all are perfect in your branch subject, course program subjects, but mathematics is not very easy for you, and therefore I suppose you observe or you view the videos frequently, twice, thrice, 4 times, etc., and try to solve the examples of your own. After completion of this topic, I will again send the notes on these partial derivatives. So for today it is sufficient. Stay home, stay safe. Thank you very much.